Section 6 begins our study of the statistics portion of Chapter 11. There's a lot of vocabulary in this section, and really some of the other sections that we're going to do as well. Lots of vocab. You need to know what these words mean, and you need to know how these words are used. Some of these words are going to be used on your district assessment, which is coming up after we finish this chapter. Your ability to work with mean, median, and mode, and also standard deviation, a couple other things, will dictate how well you do on your second district assessment for this class. So first of all, measures of central tendency. The measure of central tendency is a statistic that indicates the center of a data set. Measure of central tendency. You guys know what tendency means? Like likely to occur or something like that. If you tend towards using your right hand when you write, then you have a right-handed tendency. Okay? So measures of central tendency are these guys right here. They are mean, median, and mode. Those three things are the measures of central tendency that we're going to be working with. The mean is another word for the average, and you know how to find the average of something. So the average of a set of numbers. The common symbol is X bar. You read that as X bar. It's just an X with a bar over the top of it. That's all it is, X bar. The median is a middle number, the middle number of a set of numbers. Or, if you wind up in the middle of two numbers in your data set, then you just take the average of those two middle numbers, and that gives you the middle of the middle numbers. So the median is the middle number in a data set organized from least to greatest value. This is important right here. You cannot find the median of something unless you have organized the data from least to greatest value. The mean doesn't matter. You just add up all the numbers that you have, divide by the number of numbers that you added together, and you have your mean. But the median, you have to have the set in order. The mode is the most frequently occurring value of a set of numbers. So if I have a whole string of numbers and I got one number that occurs 25 times more than any other number, then that number, whatever it is, would be the mode. It's the one that occurs the most. Out of the three of these measures of central tendency, the mean and the median are the ones that are used the most frequently. They're the ones that have the most meaning. The mode usually doesn't have as much meaning as the median and mean. However, there is frequently a use for the mode, even though it kills me to say that because I'm not a big fan of using mode for any reason. There are times when the mode is useful. So the average value or the mean value is usually used when you have a whole bunch of data and you just want to figure out what number kind of matches all of those numbers. That's kind of like your grade is an average most of the time. The median finds a middle number. If you want to know the number that is directly in the middle of the data set, you're going to find the median. The mode is the one that is used the most often. So the best example I can think of that you would want a mode for is if, like around graduation time, sometimes people give money in cards. And you want to know how much money to give. So then you'd go around saying, hey, how much money are you giving in the card for so-and-so? The answer most commonly given might be the one that you choose. Like if you ask 20 people and 15 of them said, oh, I'm giving 20 bucks to this person, what are you probably going to give? 20 bucks probably, because that's what most people are giving is 20 bucks, okay? Whether you think that's a lot of money or not, I don't know, but that's what most people are giving in the card, so that's what you're going to give. That's the mode. That's about the easiest example I can think of where mode is useful. Otherwise, it's usually not useful. Okay, so let's find the measures of central tendency for the following data. It says data sets, but there's only one, so let's just go ahead and find the measures of central tendency for these. We have three. X bar is what? The mean. So to do the mean, how do we do that? We add them all up, and then we divide by the number of things we added together. So I can write that down as 1 plus 2 plus 3 plus 3 plus 4 plus 5 plus 5 plus 9, all divided by how many things are there here? 1, 2, 3, 4, 5, 6, 7. There's 8 things. So it's all divided by 8. What do we get?
4.
4? So the mean is 4. The median. Do we have a symbol for median? No, so what should I write? Just median? Okay, to find the median, we go for the middle number. And the nice thing about having an ordered set of data is what we can do is just kind of chop off the ends. So we take out these two numbers, we take out these two numbers, we take out these two numbers, and we're left with 3 and 4. If we were left with just one number, then that one number that we were left with would be the median. But we're left with two numbers. So we have to find the number that's directly in between that 3 and 4. What is the number that's directly in between 3 and 4? Yeah, 3.5. So that's how you find the median. It's very easy, as long as things are in order. What about the mode? Okay, so looking at these numbers, which one occurs the most? Let me erase. Yeah, you notice that the 3 is repeated. We see that one twice. But the 5 is also repeated. So in this case, we actually have two modes, 3 and 5. There's no special way, no. We're just going to write mode, and we have two modes on this one, 3 and 5. And actually, if you look below, the vocab down here, bimodal, is a data set that has two modes. So this would be a bimodal data set because of the fact that it has two modes. If a data set has more than two modes, so we can have no mode, we can have one mode, we can have two modes. If the data set has more than two modes, then the modes are probably not statistically relevant, and we just ignore the mode then. If no value occurs more than any other number, then there is no mode at all. So it's possible to have no mode. It's possible to have one mode. It's possible to have two modes. Anything more than two, and we're not going to talk about mode. So let's take a look at this frequency table here. This table that we see over to the side is called a frequency table. It's important that you realize that it's a frequency table because they're not just giving you data. They're telling you how many times a certain piece of data occurs. That's what frequency means. Okay? So we have the number of job offers received by each student within 2 months of graduating with a mathematics degree from a small college. So we can call it Bob's College if we want to. What are the mean, median, and mode for the job offers per student? We need to realize what this table is showing us. It's not showing percentages. It's showing students. How many students got 0 job offers? So how many data points did I just look at there? There's 2. Both of them are zeros. Student number 1 had no job offers. Student number 2 had no job offers. How many job offers did student number 3 have? If I read this table, I got 2 students with 0 job offers. I got 2 students with 1 job offer, so I have a 1 and a 1. Then I have 4 students with 2 job offers. So I have what? 2, 2, 2, 2. Good. Then I have 5 students with 3 job offers. Is that 5 threes? Okay. And then I have 2 students who had 4 job offers. 4 and 4. That's what that frequency table was telling you. It was a nice compact way of showing you how many job offers each individual student had within 2 months of graduating from Bob's College. Now we can calculate the measures of central tendency. So for X bar, what do we have? Maybe we can do it in our heads, I don't know. We've got 2, 4, 6, 8, 10. Another 15, that'd be 25, and 8, 33. How many students were there? 15? Did you sit here and count 1, 2, 3, 4, 5, 6, 7, 8, or did you go over here and say I had 2, 4, 4, 5, and 2. The frequency table can still be used for that purpose. So we have how many? 15. So 33 divided by 15, control enter, what do we get? 2.2. So the average amount of job offers for the students who graduated from Bob's College within 2 months was 2.2 job offers on average per student. How about the median? To do the median, we have our organized list of data here to start lopping off things from the ends. So those are gone, and then those are gone, and then those are gone, and then those are gone, those are gone, those are gone, and I'm left with 2. So the median was 2 job offers per student. One more, the mode. How do you know it's 3? Because 3 occurs the most up here? Yeah, if you look on the frequency table, the mode becomes very easy to pick out. You can do the mode actually immediately before you even write anything else out. So the mode here is 3 job offers. Now notice that the median, the mean, and the mode are all basically very close to each other. Either 2 or 3 for the most part. That's kind of an important thing. You want the average and the median and the mode to all be pretty much the same thing. If the median and the average were far apart, then things would probably be kind of weird. For the second one, a frequency table again shows the number of trees in the yard of each house on one street. What are the mean, median, and mode for the trees per yard? Well, what can I do first? Mode. What is the mode? Mode is 5. The number of trees per yard. There are 5 trees in 7 yards, and that's the most that we wind up with. So this guy right here is the mode. Just make sure you keep straight what it is that you're talking about here, okay? Talking about trees, so it's 5 trees. That's the mode. Okay, how about median? Median's 5. How did you find that out? Yeah, you wrote all the numbers out. So we have 1 yard with 3 trees. So what do I write? I write 1, 3. Then what? Right, 4, 4, 4, 4, 4. Then 5, 5, 5, 5, 5. And then, 6, 6, 6, 6. And then, good. And then 8, 8. Great. Now they're all written out. Now we chop off the ends until we wind up in the middle somewhere. So we chop, 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 chop. We wind up with a 5. So the median is 5. How about the mean? 2.25? The mean has a symbol. What is the symbol? X bar equals, it's not 2.25. It's 5.25. And each one of these is what? What's the unit? Yeah, it's trees per yard. So 5 trees per yard, 5 trees per yard, 5.25 trees per yard. That's how you do this, okay? When you're reading the frequency table, though, be careful. Make sure that you're writing down the correct numbers, not the 1, 5, 7, 4, 1, 2. You're writing down 3, 4, 5, 6, 7, 8. More vocab. Outlier. We should have learned outlier before. If you learned about mean, median, and mode back in elementary school, then you should have also learned the word outlier. An outlier is a value that is way different than the rest of the data, substantially different than the rest of the data. So all my data is kind of hovering around 10 or 12 or something like that, and then all of a sudden I got something that's 192. That's an outlier. Or all of your test scores were kind of hanging out around 75%, 80%, 90%, somewhere in there, and then I got somebody who got a 22. Okay, that's an outlier in a bad way. So we do have outliers out there that we have to talk about. Range of a data set is the difference between the greatest and the least values. And we're using this letter capital R for range. And it's very easy. You just find the highest number, you find the lowest number, and you subtract the two. Quartiles are something that are probably new to you. So for quartiles, the median divides a set of data organized from least to greatest in half, 2 equal parts. The quartiles divide the two halves into equal parts as well. So what happens is you wind up with 4 equal parts. So if I have a data set, I'm just going to make up a number line here for a data set. The lower number would be over here. The highest number would be over here. The range would be this number minus this number, and that would give me this length. Then the median would be the middle number. That divides the data in half. Half of my data is on this side, half of my data is on this side. The quartile, by the way, the prefix that you see in quartile is the same prefix that we use for quarters. How many quarters are in a dollar? How many quarters are there in a basketball game? How many quarters are there in a football game? How many quartiles are there in a data set? Same thing, okay? So the quartiles divide the first half of data into 2 more pieces of data, and the second set of data gets divided into 2 more pieces of data, quartile 1 and quartile 3. The median is quartile 2. So now once I've done that, I've divided my data set into 4 pieces. The first piece, the second piece, the third piece, and the fourth piece. The first quartile, the second quartile, the third quartile, and the final, the fourth quartile. The interquartile range. A lot like the range of the entire data set, the interquartile range is just the difference between the third and first quartiles. And we use this abbreviation for interquartile range, IQR. So you'd just be taking this number minus this number instead of the whole thing minus the other side. All right, the next few examples work with all that vocabulary that we just learned, starting with an outlier. So let's take a look at this data set here. Which one of these numbers would be maybe considered to be an outlier? Yeah, because all of my other numbers, 56, 65, 73, 59, 65, 59, they're all kind of hovering around the same kind of general area. But this 98 right here, way out there. So if these were test scores, well, I got like all D's and F's, except for one person who got a 98% on it. It'd be pretty awesome for that one person, but pretty terrible for everybody else. So the answer here must be C. That's the outlier. Thank you. Suppose the numbers in the above set, so we're still looking at these numbers right here, are taken from one of these two situations. Would you discard the outlier? Because a lot of times when we have outliers, we just kind of ignore them because they screw up our data. Would you discard the outlier here if we have water temperatures of a lake at 7 locations? That's where these numbers here came from. Why not?
Because it depends what you're trying to do with the water temperature.
Well, I just measured a bunch of water temperatures at 7 locations in that lake. Yeah?
You can't just discard a location out of a lake.
Yeah, but one of those was 98 degrees. Just that one spot, the sun's shining right there?
It was off cliffs.
There's something causing that lake to have a higher temperature.
What could be causing a lake to have a higher temperature in one little
A
spot?
volcano.
Oh, yeah, we have a lake over there that does exactly that, right? It has hot spots in it. The lake itself, you don't want to swim in because the water temperatures are super cold and you'd have hypothermia very, very quickly. However, there are volcanic vents in that lake that cause warm water in certain locations. So if we were talking about Yellowstone Lake, would this 98-degree water right here surprise you? No. But what if we're talking about Sunshine Reservoir or something like that?
Yeah.
Would this 98 degrees right here surprise you? Yeah, probably. Unless a little kid just swam by it, right? Then there might be a problem. Do you agree? That could kind of skew the results. Yes, exactly. So what can we say here? Would we discard the outlier? No, but it depends on the lake, yeah. And whether or not there's any 7 or 8-year-olds swimming nearby.
But, like,
Are you going to say that 15-year-olds and 16-year-olds could have caused that same problem?
no, I'm saying, like, in a lake like that, so you go swimming in a hot spot?
Yeah, you don't want to, but yeah. Second one, the number of customers in a restaurant each night of the week. We would discard the outlier there or no? Why not?
Why? Or like a Friday night.
There you go, yeah. Both of those great ideas right here. We have 98 people showing up to a restaurant on a certain night of the week. Maybe that was, I don't know,
Super Bowl.
Friday night. Maybe it was the Super Bowl. Maybe there is a reason why this number right here is 98. But if this was a random Wednesday afternoon or something that we took that data, then maybe, yeah, we would discard that. Because maybe a tour bus showed up or a motorcycle gang or something like that. Okay? So would we discard this one? No, we would probably not discard this one. And why not?
Because
The most simple explanation, Friday night. People go out to dinner on Friday night. So restaurants see a higher number of customers. All right, so that was outlier and whether or not we discard the outlier. Now we need to talk about the mean, median, mode range and interquartile range. So we have the table showing the average monthly water temperatures for 4 locations on the Gulf of Mexico. It scares me to ask if you know where the Gulf of Mexico is. Okay, good enough. Not north, right? Okay. So how can you compare the 12 water temperatures from St. Petersburg with the 12 water temperatures from Key West? What state are these two cities in? They're both in Florida? They're both in Florida. So, this is asking us to calculate all of these values and then compare those values and make some sort of statement based on what we see. It's asking us to compare the mean, median, mode, range, and IQR. So we have all this data sitting here for St. Petersburg and for Key West. For St. Petersburg, what should we probably do? We got to find the average, so we can add them all up. We want to order them from least to greatest so that we can do the median. So what's the smallest temperature that we have? Okay, so I'll go St. Petersburg, STP. We have 62, then what? 64. There's another 64. Okay. 68. Okay. All right, 74 and then 78. We got two 84s. 86 and 86. Okay, now the data set is ordered, which means it's going to be easier for us to calculate some of this stuff. So, we need X bar, the average. We need the median. And we need the mode. We need the range. And we need the interquartile range. To do the interquartile range, we have to find the quartiles. So we'll have to do Q1 and we'll have to do Q3. And that will allow us to do the IQR, the interquartile range. So we have to find all of that stuff for St. Petersburg, and then we got to do the same thing for Key West. Yeah. So let's do median. To do the median, the 62 and the 86 are gone, the 64 and the 86 are gone, the 64 and the 84 are gone. The 68 and the 84 are gone. The 70 and the 80 are gone. And I'm left with two numbers, 74 and 78. So what's the median? The number that's in the middle of 74 and 78 is 76. So the median is 76. What's the mode? The number that gets repeated the most? We have 64 twice. We have 84 twice. We have 86 twice. So what's the mode here? Why is there no mode? Yeah, it's probably not statistically relevant to say what the mode is because we have a bunch of things that are repeated the same amount of times. So we're going to go with nothing here, no mode. NA would be perfect, actually. All right, we still need the average. Did somebody calculate that yet? 75 exactly? Okay. So let me get that written down. And then we need to figure out the range. How do we do the range? High minus low. 86 minus 62, what do we get for an answer there? 24. Okay, we'll talk about what all these numbers kind of mean in this situation here in a little bit. Quartile 1. So to calculate quartile 1, the first thing I want to do is take my data set and divide it into two halves. Where's the median at? The median is between 74 and 78, right there. That's the median. Now I have this side of my data set. I basically want to find the median of that data set. So those two are gone, and I'm left with these two numbers, which means that the median of this side of my data set is 66. The number in between 64 and 68 is 66. So that is quartile 1 right there. It's 66. So I can write 66 here. Now I got to do the same thing on the other half to get quartile 3. So I chop off the 78 and the 86, the 80 and the 86, and then I have 84 and 84. What's the number directly between 84 and 84? 84. So Q3 is 84. So now we can do the IQR, the interquartile range. What is it?
18.
It's 18. 84 minus 66. Q3 minus Q1. Now we need to do the same thing for our other city, Key West. So what should I do first? Order them. The lowest number is, so I'll go with KW for Key West, and we have 69. What else? A 70, 72. Next one's 75. Okay. Okay. 82, 82. 85, 86, 87, 87. All right. So now they're in order. And for Key West, we need to do the same stuff. So we have an X bar, median, mode, range, Q1 for the interquartile range, Q3, and then finally we can do IQR. All right. Do we have an average yet? A mean? 86.3. And the median is 80. We chop off the 69 and the 87, and then there, and then there, and then there, and then there. And we wind up with 78 and 82. The number directly between those is 80. Good? How about a mode? 82 and 87 here. Okay, how about a range? 18. And how about a Q1? Range is the highest value minus the lowest value. So the median here is 80. It's right there, directly between the 78 and the 82. That's your median. So to do Q1, where am I going to be? Directly in between the 72 and the 75. So the number that's between 72 and 75 is 73.5. So we have 73.5 here. And for Q3, we are directly between 85 and 86. The number that's directly in the middle of those two numbers is 85.5. Yep, you're just doing the median of the first half and then the median of the second half for your quartiles. Now for the interquartile range, exactly 12. Okay, now we got to answer the problem. It says, how can you compare the 12 water temperatures from St. Petersburg to the 12 water temperatures of Key West? Well, take a look at these numbers that we're looking at here, and we can say a lot about these two cities. The range of temperatures, average temperatures for St. Petersburg is 24 degrees. So as the year goes on, the average temperature changes by 24 degrees. But in Key West, the average temperature only changes by 18 degrees. In St. Petersburg, the average temperature is 75 degrees, but in Key West, the average temperature is 86 degrees. Key West is way nicer. Not only is it an average temperature that's warmer, as the year goes on, the temperature swing is less than St. Petersburg. The majority of the data here lies between Q1 and Q3. So most of the time, you're going to be between 84 degrees and 66 degrees. For Key West, most of the time, you're going to be between 85.5 degrees and 73.5 degrees. Which one sounds better? Key West. So just by looking at these numbers and analyzing these measures of central tendency that we have, we can kind of make a claim as to which city is better to live in if you're looking for a warm climate. Which one is it? Key West is probably better. Okay? So that's what a problem like this is asking you to do. There's more that you can do with it, but just on the general surface of working with numbers, this is how you do this problem. So now I want you to repeat the problem for Dauphin Island and Grand Isle. Where are those located? Alabama and Louisiana. So we want to repeat this problem for these two cities. If it were me, I'd be using a calculator. Oh yeah. All of these things are easily calculated by using your calculator. So we are going to enter in the data for both of these locations on the calculator. Go to your spreadsheet. If you haven't cleared the memory yet, it's possible that somebody has something on there. So let's go to our spreadsheets. Once you've cleared the memory, and we can go with Dauphin Island, call it DI. And then we're just going to enter the data in exactly the way that we see it. We don't have to order it. The calculator doesn't care. You just got to enter it in correctly. So 51, 53, and so on. Once you're done with that last cell, make sure you press enter. Stay in that column. Okay, so once you're here, press menu and notice the options. Which option do you think we're probably going to take? Yep, statistics. So option 4, and then we want stat calculations. That should be option 1 for you guys. And then one variable statistics. We are working with just one variable. There's only one thing going on here. Temperature. for a city. Okay, so it's one variable statistics. So that's the one that we want. And then we have a number of lists. There is only one list. So you're going to leave that alone. It should come up as 1. So hit OK. The list that you want is defaulting right now to the column that you're in, which is why I said stay in that column. So that's fine. It should be in A. If it's in a different column, you just change it to that column that you want it to look at. The frequency list, leave that alone. Category list, leave it alone. First result column. This is where it's going to display the results for these calculations. So putting it in column B is going to be perfectly fine because we don't have anything in column B. If you want it in a different column, you just change the letter. So that all should be fine. Go ahead and press OK. And now you have all of your data sitting right here. What is that first one? What is it though? That's the mean, yeah, x bar. So that symbol, x bar, is our mean. 69.1 basically degrees. That symbol right there, what does that symbol mean? That's the sigma. What did we do when we were working with sigma? Sigma is shorthand for a sum. So that would be the sum of all of the entries that you had. If you were to take all of those temperatures and add them together, you would get 829. If you were to square 829, you would get 58,935, the sum of all the x's being squared. Okay? Skip over those. N is the number of entries that we had. There were 12 months. We entered 12 things in, so that's why we see a 12 there. If we continue going down, we have a minimum value of 51. We have a quartile 1 value of 58, a median of 71, a quartile 3 value of 81, a maximum value of 84, and then it gives us something else down there that we're not going to be talking about. So all of the information that you need, with the exception of range and interquartile range, are all here for you. So now you can just write all those things down. So for Dauphin Island, what was our x bar again? 69.1, and what was the median? 71, and the mode? It didn't give us one, so do we have one?
84.
For Dauphin, 84 is repeated and nothing else is. So the mode would be 84. Okay, what else do we need? We need range. The calculator told us the high value and the low value, so you could just take those two numbers and subtract them. What do we get? 33. And then next, quartile 1 it gave us, which was 58. Quartile 3 it gave us 81. So therefore the IQR is 23. Much faster to use a calculator. You still have to write all that stuff down, and we still have to do Grand Isle, so I'll go with GI, and we're going to do it all again. But now the nice thing is go back to your calculator, go back to the spreadsheet. You do not have to make a new spreadsheet. In fact, leave that data on there and just move over to another row, or another column, sorry. I'm on column D now, so I'm going to call that GI for Grand Isle, and then go down and type in all that Grand Isle stuff. And then you can do the same thing. Once you've entered in all that data, stay in that column, have it go statistics, one variable statistics, and it will want to show up in column E. And then all of your data will be there all in the same spreadsheet. So that's how you finish off this problem.